Have you ever been in math class and seen a number that looks like it's shouting at you? You know, a number followed by an exclamation point? Well, that's called a factorial. And in this explainer, we're going to dive in and figure out what it's all about. So seriously, why is math so excited all the time? Well, that N isn't actually a shout of excitement. It's really an instruction, and it happens to be one of the most powerful and useful shortcuts in all of mathematics. So let's decode what it really means. All right, first things first, what does this mathematical exclamation point actually do? Let's start with a really simple definition and a crystal clear example. You know, the core idea is surprisingly simple. The factorial, which we write as n factorial, is just a shorthand for a specific kind of multiplication. It tells you to take a number, n, and multiply it by every single positive whole number smaller than it, all the way down to 1. Let's make this real with 5 factorial. As you can see, you just start with 5, then multiply by 4, then by 3, then by 2, and finally by 1. You follow that chain of multiplication, and you get 120. Simple as that. Now check out this table. This is where things get wild. Look at just how fast these factorial values grow. At 2 factorial, we're at 2. No big deal. By 5 factorial, we're already at 120. But by the time we hit 10 factorial, the number has absolutely skyrocketed to over 3.6 million. This isn't just growth, it's explosive. Okay, so we know how to calculate it, but what is it actually for? What's the point? Well, its most fundamental use is surprisingly simple. It's for counting possibilities. At its very core, a factorial answers one key question. How many different ways can I arrange these things? In mathematics, this idea of a unique arrangement has a special name, a permutation. So, anytime you need to find the total number of unique ways to order a set of items, you're going to be using a factorial. Imagine you have 3 different books. How many ways can you line them up on a shelf? Well, for the first spot, you have 3 choices, right? Once you've placed one, you only have 2 choices left for the second spot, and then for the final spot, you've only got 1 book left. That's 3 times 2 times 1, or 3 factorial, which gives us 6 possible arrangements. The factorial gets us the answer instantly. And now for the part that trips up just about everyone, the 0 factorial. It's a rule that feels really strange at first, but it is built on pure, solid logic. So let's solve this little mystery. We know that 1 factorial is just 1. That makes perfect sense. But why on earth is 0 factorial also 1? Shouldn't it be 0? It's a great question, and it turns out there are a few excellent reasons why it simply has to be 1. Let's just go back to our basic definition. A factorial counts the ways to arrange a set of items. So let's ask, how many ways can you arrange an empty set, a set with 0 objects in it? Well, there's only one way. You do nothing. That single arrangement of an empty space is a valid outcome, and because of that, 0 factorial has to equal 1. If that feels a little too philosophical, don't worry. The math itself gives us a very clear answer. Just look at the pattern. To get from 5 factorial down to 4 factorial, you divide by 5. To get from 4 factorial to 3 factorial, you divide by 4. If we follow this logical pattern downward, to get from 1 factorial to 0 factorial, what do we have to do? We have to divide by 1. And 1 divided by 1 is 1. The pattern holds up perfectly. And finally, 0 factorial has to be 1 because it's the missing puzzle piece that makes so many other areas of math work. For instance, think about this. How many ways can you choose a group of 3 items from a set of 3? Obviously, just one way. You take all of them. Well, for the big universal formula for combinations to give us that simple answer, 0 factorial must be defined as 1. It completes the puzzle. So now that we've demystified it, let's see where this powerful tool actually shows up. It's not just for counting books on a shelf. It's a real cornerstone of many advanced fields. A perfect example of its power is how it helps us tell the difference between permutations and combinations. In permutations, order is everything. Think of a race where first, second, and third place are completely different outcomes. But in combinations, like picking a team, the order doesn't matter at all. They're totally different concepts, but guess what? The factorial is the essential building block you need to calculate both. And its reach goes even further. In probability theory, it's used all the time to calculate the likelihood of specific events. In calculus, it's a key part of the infinite series that defines the famous number e.
And in computer science, it's a classic tool for teaching recursion and figuring out how efficient an algorithm really is.
Speaking of programming, the idea of recursion allows for an incredibly elegant way to define a factorial. A function can simply call itself with a smaller number over and over until it hits what's called the base case, the point where it knows the answer is 1. It's this beautiful, self-contained loop of logic that perfectly mirrors the factorial's mathematical nature.
So we started with a simple exclamation point, and what do we find? We uncovered a concept that helps us count vast possibilities and serves as a key ingredient across science, math, and technology.
So what are the big takeaways here? First, the factorial is a simple shorthand for multiplying a descending chain of numbers. Second, its real power lies in counting permutations, or all the possible ways to arrange things. Third, that weird-looking rule that 0 factorial equals 1 is absolutely essential for keeping math logical and consistent. And finally, this little symbol is actually a giant, a fundamental building block in fields from probability to computer science. And that leaves us with a final thought. We started with a simple exclamation point and found a whole universe of complexity and application. It really makes you wonder, doesn't it? What other simple mathematical ideas are out there just hiding incredible, world-changing power?